All right, so the multiplication property of exponents, we're going to use this when we have two different things next to each other, either with like a time symbol in between them or two sets of parentheses. So the first thing we're going to do is multiply the coefficients. So in this case, my coefficients are the numbers in front, which are 5 and 3. So I'm going to multiply the 5 times the 3, and that's 15. I'm going to keep the base the same. The base in this case is my variable, which is x, and instead of writing that twice, I'm just going to write it once. And then I am going to add my exponents together. My exponents are my little numbers, which are my 2 and 9. So I'm going to add them together to get 11. So 15x to the 11th. You can check your answers to these. Because there's a variable involved, it would have to be in the y equals screen. So I could do 5x to the power of 2. Then I'm going to arrow out, and then times 3x to the power of 9. And then in y2, 15x to the power of 11. And then I can just make sure that my tables match completely. So you don't have to do that, but it is a way, a resource to check your answers. All right, so for this next one here, I am going to multiply my coefficients, which are my numbers in front. I'm going to keep my bases the same. There are actually two bases here. X is one of the bases, and y is a different base. And then I'm going to add my exponents. The thing is, some of these variables don't have exponents. So this x doesn't have an exponent. I have to put a 1 there. The y does. This y does not. So I'm going to add the exponents of the x's together and then the exponents of the y's together. So multiply coefficients, 3 times -2 is -6. Keep the x the same, add the x exponents together. So I'm going to add 1 plus 3. Keep the y variable the same and add the y exponents. 4 plus 1 is 5. You just can't forget to add the 1's. All right, last one. I'm going to multiply the numbers in front. 10 times 2 is 20. I'm going to keep the x the same, and I'm going to add the x exponents together. -6 plus 10 is 4. And then I'm going to add the y exponents together. -3 plus 3 is 0. Y to the 0 means that you don't have any y's. So I'm not going to write y at all. My final answer for this one is going to be 20x to the 4th. I'm not including the y to the 0 in that answer. The next property of exponents is the division property of exponents. And I'm going to do the division property of exponents when I see fractions. Let me just move this. All right, here we go. So when I see fractions, so the first thing that I'm going to do is I'm going to divide the coefficients. Top number divided by bottom number. If you get a decimal when you do that, you have to enter it on the calculator. But in this first one, I don't get a decimal. 8 divided by 2 is just 4. Now there are two parts of the fraction, the top and the bottom. There's a 9 on the top and a 3 on the bottom. Since 9 is bigger, the x is going to stay up top. And then I'm going to subtract 9 minus 3. The bigger exponent 9 minus the smaller exponent 3. 4x to the 6th. Now for this next one, when I do top number 10 divided by bottom number 18, I do get a decimal. So I'm going to enter that, and I'm going to write this as 5/9. I have an x exponent of 6 on the top and 15 on the bottom. So since 15 is bigger, the x is going to stay on the bottom. And I'm going to do 15, which is the bigger exponent, minus 6, which is the smaller exponent. And so my answer looks like this. When I do 3 divided by 12 for this next one, I again get a decimal. So I'm going to enter. and write this as 1/4. For the x's, I would do 8 minus 8, which is 0, which means the x's cancel out. I'm not going to write the x's at all. For the y's, I'm missing an exponent on the bottom y, so I'm going to write a 1. The exponent of 3 on top is bigger than the exponent of 1 on the bottom, so I'm going to keep the y on the top. And 3 minus 1 is 2. I don't need to write the 1 though, so this is the same as y squared over 4. If you wrote the 1, that's totally fine. You can keep it that way. You just don't have to. All right, and for this last section here, what makes the power property different than the multiplication property is you're going to see parentheses in each, but in this one, there's only one set of parentheses and there's a number on the outside of it, whereas for the multiplication property, that's not the case. There's 2 sets of parentheses and there isn't a number on the outside of it. So I'm going to raise the coefficient to the power on the outside. So what that means here is I'm going to do 3 to the power of 4. And I'm going to type that in my calculator using this button here. It's right below the clear. Or 3 to the power of 4 is 3 times 3 times 3 times 3 times 3. Either way, I'm going to get 81. So this is going to become an 81. I'm going to keep the base the same, and I'm going to multiply the exponents. So 6 times 4 is 24. All right, so for this next one, I'm going to raise the coefficient of 4 to the power on the outside of the parentheses. And I'm going to type that into my calculator. So 4 to the power of 3, or 4 times 4 times 4. 64. Keep the base the same and multiply the exponents. So 7 times 3 is 21. For the last one, I'm going to take the coefficient and I'm going to raise it to the power. The only thing is if the coefficient is negative, you have to use parentheses. If you don't, you will get the answer incorrect. It comes up negative, but -2 6 times should be a positive number because a negative times a negative ultimately ends up as a positive. How many is that? 6. So you see it should be positive 64. You just want to make sure you use parentheses with the negative numbers, and this should end up being positive 64. So 64, keep the base, and I'm going to multiply the exponents. The x inside doesn't have an exponent, so I'm going to give it a 1, and I'm going to do 1 times 6. Hopefully this helps. Tomorrow we are going to change all of the exponents that we just did to fractions. So it's important that you understand how to do these exponent properties with whole numbers, because it's only going to become more complicated when we add in fractions. And then once we add in fractions, we can then start to turn these to roots, because exponents that have fractional exponents can become roots.